Hey everyone, let's get working on the latest stuff with triangles. What we're working on now today is bisectors, medians, and altitudes. The warm-up is going to be some stuff we worked on yesterday about the special right triangles. I know a few of you at home kind of said that you were confused, so just try them. We'll go over them again on Monday when you're in class to kind of go over that and see what our confusion is and where they are. So just give these a few minutes, try them. See what the answers are, plug them into Edpuzzle, and then we'll come back and we'll go over them as we go through. Okay, so you're back now, and remember, we had the two types of triangles, 45, 45, 90, and 30, 60, 90. And then the 45, 45, 90, those are the ones that are going to have, we're going to have to deal with square root of 2 in some of our answers. And then the 30, 60, 90, we're talking square roots of 3. We may have that in some of our answers, and we may not. So like if I kind of quickly draw a little chart, kind of go with the 45. So this is a 45. That's 90. Then that we know our legs are both going to be x. The hypotenuse then is x square roots of 2. For the 30, 60, 90, shorter leg, we know, and this is 60. Sorry, it's so small. I know my short leg is going to be x. The hypotenuse, the side opposite the right angle, is 2 times x. And then our long leg is x times the square root of 3. So what you're hoping for on the test is that I'm giving you legs in whole numbers, or hypotenuses in whole numbers, or the side that has a square root of 3 in that form. What you don't want to see is like the hypotenuse of a 45, 45, 90 triangle as a whole number, because then you're going to do a little bit of math, if we remember that. So in our example number 1, we have our leg is 14, so we look at our kind of quick diagram. I know then that my hypotenuse is going to be 14 times the square root of 2, because that's all it is. It's just x square root of 2. 2 is the example where the hypotenuse is 45. Remember, we can work that through by setting 45 equal to x square roots of 2. So now we just can solve this for x if we need to. We end up with x is going to equal, I want to flip sides here for a minute, 45 times the square root of 2, which, like we talked about yesterday in the video, is we got to get rid of the square root of 2. So we're going to have to rationalize the denominator by multiplying both the top and bottom by the square root of 2. My understanding is some of you may have had a teacher last year that didn't cover this. I'm sorry about that. We'll kind of go over it again on Monday just to make sure it makes sense. When we multiply square roots of 2 together, that just becomes 2. So now my denominator is 2. The top is 45 square roots of 2. So I can leave that for x here that way. I can have x be in the 45 square roots of 2 over 2. Or if you want, you can make it 22 and a half. You kind of want to figure out, or 22.5 square roots of 2. Perfectly fine. Don't mind it. That's what you want to do. That's fine. Problem 3, the leg was 22. That's what I want to see is a whole number leg, so I can just make my hypotenuse, whoops, not 33. 33 is not going to work for me. Where'd my eraser go? There it is, over here. Sorry about that. Give me 2 seconds. 10. So my hypotenuse for this one becomes 22 times the square root of 2. These are all 45. Next one is just be the 30, 60, 90. So again, we're working with the 45, 45. Here I have 210 equals x times the square root of 2. Remember the trick we showed you when we kind of got down to number 2, we ended up dividing by 2. So that's the trick you can kind of go right to. If I can divide 210 by 2, that's actually going to be 105. Whoops, not 150. Let me start this over. Give me a minute. Okay. So the shortcut for these types of triangles, rather than setting it up and doing 210 equals x square root of 2, is we're eventually going to divide by square root of 2. We look back to number 2 where we saw We're dividing by the square root of 2, so we have to rationalize the square root of 2 out of our denominator. So when we do that, we end up with 2 in the bottom of our fraction, which we're going to divide the top by. So if you see right away that you can divide the hypotenuse by 2, I would just jump right to that. I have 210 divided by 2 equals 105. But now for my leg, if we look at kind of what we have, I'm going to need to add the square root of 2 in for my leg as well. So this really is 105 square root of 2. Okay? That's the shortcut. I'll do it out here the long way just so you can see. We're going to divide by the square root of 2, both sides. So I'm left with x equals 210 over the square root of 2. Rationalize the square root of 2 away, multiplying by 2 over the square root of 2. That leaves me with 210 times the square root of 2 over 2 times 2. The square root of 2 times the square root of 2 is 2, so that leaves me with 2. And again, I can simplify that down because I can divide 210 by 2. It's 105 square root of 2. I definitely recommend trying to kind of remember that the trick, the little shortcut there. Once you get that down, that's the best way to go because everything works through pretty quickly. Here again, we got a leg is 88, so that my hypotenuse just becomes 88 square root of 2. Those are the problems we'd love to see on the test all the time. Here's a little different. My leg has the square root of 2 number in it already. So I can either remember and work the trick backwards, or we just know my long side here now is x times the square root of 2, right? So I can do that out. My x is 5 square roots of 2, and that's times the square root of 2, which now becomes 5 times 2 times, remember, just like we rationalized the denominator, square root of 2 times the square root of 2 becomes 2. So that makes our long side there, x equals 10 for problem 6. Hope you were able to work those through, like I said. I know some of you mentioned you had some issues with it in class. So what we're going to do is we're going to go over them again on Monday, just a kind of quick refresher and do that. The next page was the 30, 60, 90 ones. Again, I hope you were able to work these through on the warm-up side and were able to do them. We'll kind of walk through them pretty quickly here and see, because exactly problem number 7 and problem number 9 and problem number 10 are the easier of the ways to do it, because the sides they've given us as whole numbers are sides we want to see as numbers. So remember when we looked at this, I'm going to kind of write them out on the side here. This is my x side. Actually, I'm going to call them sides right now, because I don't want to mix them up with the variables that are there. So we'll call that the short side. This here is going to be 2 times the short side, and my y value, the long leg, is the short side times the square root of 3. Kind of remember that through. We want to kind of put that in our heads and our brains to remember, oh, that's how it is. Now, in my example, the short side is 9, so x is going to be 2 times 9, which I think we all know is 18. My leg here is going to be 9 times the square root of 3. Does that make sense to everyone? Everybody kind of see where we're getting at, how the s's are. I plug the s's in there just to kind of hold the space on the equations. Again, I'm going to come back to number 8 so we can kind of go over that at the end. Number 9, again, we have our short side is 20. That makes my hypotenuse 20 times 2. So y equals 40. The leg is 20 times the square root of 3, which is 20 square root of 3. And we're doing these problems all day long, just kicking them out, hoping we have 30 or 40 problems like this in the test that are each worth 2 points, because that's quick free points I look at it. Number 10, kind of crooked picture, but again, the number that's the side they gave us that is the whole number is the side we want to see in a whole number. Remember, the long hypotenuse side is the 2s side, so I'm going to divide that by 2 to get my short side, which is 49 for x, and then my y side then becomes 49 times the square root of 3. So again, those are the 3 simpler problems, because our numbers were giving us numbers rather than having to solve things out. On number 8, unfortunately, they gave us the long side, the hypotenuse, as 2 square roots of 3, or 4 square roots of 3, sorry. So again, I'm going to plug this in for x. I know my hypotenuse side is the 2x side. So just like we've done before trying to solve the other ones, I can do 2x side is going to equal 4 square roots of 3. To solve for x, we're just going to divide both sides by 2. So now I have x equals 4 divided by 2 is 2 square roots of 3. So that tells me the short side, which is y in this example. Sorry, I should have made it y, but the short side here is 2 square roots of 3. Okay? Hope you saw that. Now remember, the long leg is the square root of 3 side. So that's the short side times the square root of 3, which is just 2 square roots of 3 times 3. Oh, sorry, times the square root of 3. So that just becomes 2. The square root of 3 times the square root of 3 simplifies to 6. So that makes my long leg side 6. So this is 6. Did everybody see that? Everyone makes sense? Hoping it's helping now. Yeah, we can kind of work through it. Like I say, we'll go over it again on Monday. Bring all your questions to class on Monday, and we'll go over them. So now the new stuff. Perpendicular bisector. We learned what a bisector is before. Bisector cuts something in half into 2 equal sides. Perpendicular bisector just kind of expands on that. And what it is, if I kind of draw a line segment down here, I'll try to do the best I can. My perpendicular bisector is a point that creates a right angle because it's perpendicular. But then what it does is it makes these two sides congruent. So it's cut it in the middle, it's the middle. And then as we kind of talk through and walk it through, what ends up happening then is any point along the perpendicular bisector, kind of foreshadowing here, I'm going to do it in blue. So any point in blue here on the perpendicular bisector ends up being, if we kind of drew segments out from that point to the endpoints of the bisected segment, these now are congruent. No matter where the point is, those sides are always going to be congruent. And from that, we kind of have a couple theorems that work through, kind of look at them. So we have the perpendicular bisect theorem, which tells us if the point, which is what I just explained actually, if a point on the perpendicular bisector of a segment, then it is equidistant from the endpoints of those two segments. So kind of think of it as an isosceles triangle then. The point is going to create an isosceles triangle with the bottom segment. The converse of that again is if the point is equidistant from the endpoints, then it's on the perpendicular bisector. Again, we can always kind of do the converse of all our conditional stuff. That's all these theorems really are. And then the third one's a little tricky. The perpendicular bisectors of all three sides of a triangle, because a triangle does have them, intersect at a point called the circumcenter that is equidistant from the vertices of the triangle. So if we kind of look at this picture here, we see that we have all these bisectors. They don't necessarily have to start at a vertex. So don't think it has to start at a vertex. And what they do is we've created right angles all on all the sides of the triangle. So those are the perpendicular bisectors. What we haven't shown is those are congruent, these are congruent, and then these are congruent. To mark up our picture a little bit. So this point P here in the middle, that is the circumcenter. We'll talk about that in a minute as we kind of go through the stuff. Just remember that the circumcenter is the point where all the vertices cross. Okay. An example to do math from that now. We see our picture of our triangle. We're given a right angle. We're shown the right, whoops, what happened? I zoomed, I didn't want to zoom. Oh, okay. There we go, what just happened? Technical difficulty, sorry about that, everyone. So, they drew a line down from the vertex. It just happened to be the vertex on this one. It created a right angle, and they're showing that these two sides now are congruent. So that's showing us that that line from the top is the perpendicular bisector. Importantly though, point F is on the perpendicular bisector. So they're telling us that side FG is 2.8. We want to find out the side for FM. So we learned just a minute ago, a point on the perpendicular bisector is equidistant from the end of the segments. That's what the base of the triangle is, so that's going to make our side FM 2.8. Does that make sense to everyone? Okay. Problem 2, our example 2 here, they've shown our triangle on its side. They've told us again it's a perpendicular bisector. It created our right angle. And then we know now it's a bisector. They told us it's the bisector. So now my side AD is going to be equal to DC. I'll write it out quickly. AD equals DC, the measurements. So they're asking us algebraically to find the value for x. So I know if they're equal, then 5x minus 6 is going to equal 3x plus 8. Now we just get algebra. Again, algebra and geometry class. We're solving for x. Add 6 to both sides. So I'm going to subtract 3x from both sides to do it all in one step. I end up with 2x equals 14. So now x equals 7. Simple algebra. Take it one step further now, I can solve for the length of those sides by plugging 7 in for our equation. I get 21 plus 8. So these are 29 units long each. Does that make sense? Everybody sees that? I think this is a little easier than the stuff we learned yesterday for you. So I want you to go through and do these 4 problems. The first 2, you're figuring out the measurements of the segments that they're asking for. And then the third one now I want you to kind of take a look at. It's asking if P is the circumcenter, what are the congruent segments for these segments that are shown here? Because the segments are going to be congruent, because remember, we're talking about the perpendicular bisectors, so at least the sides should have congruent sides. So take a few minutes, enter your answers in the Edpuzzle, and then we'll come back and go over. Okay, they're asking for XW, so they're asking for this long side. It's not the best picture, but that is our right triangle, so they're telling us that that's the right angle. That makes this, where both of these sides are 5, it's the perpendicular bisector. Point X is on the perpendicular bisector, makes the 2 edges congruent, so that makes XW 7.5. Hope everybody saw that. Here now we're looking for BF. Again, they tell us that both sides are 19, so that tells me E is on some sort of perpendicular bisector because we do have a right angle. Because these are both 19, I know it's perpendicular bisector. So that makes this 4.2, so now BF should be 4.2 as well. Because this line in the middle bisected that segment in half. Did everybody see those? Good. Point 3. Problem 3, sorry. Point P is the middle. So if these are all these arrows, the lines now, are the perpendicular bisectors of the side. So what that tells me right away, I'm just going to mark it up before we even look at what the letters are. Point Y is the point where the perpendicular bisector crosses EM, so that just tells me E, Y, and YM are congruent. Same thing with MN and NK. Same thing with ER and RK. Does that make sense to everyone? Okay, awesome. Now we kind of look and list any segments that we know are congruent. So MY, they want MY. I know MY is congruent to EY. Looks like that might be the only one. KP, wait, whoa, KP is a weird one. There's really no segment KP. If I drew that line KP, I really don't have anything. So I'm going to say nothing congruent to KP because KP is not even a line. So I'll do X or 0. Let's do 0. MN is congruent to the bottom side, so that's going to be NK. And then ER, side of the triangle, ER is congruent to RK. Does that make sense to everyone what we're doing there? You may be given a test question like that to try to give in some side lengths, and you got to figure them out that way. All right, I think we're moving on now to the note about the circumcenter. Okay, we talked about this a minute ago. Now I did the best I can to draw all this freehand. When you have a triangle, the circumcenter, we've shown it being inside the triangle. It doesn't always necessarily have to be inside. Is that the middle? No, it's close enough to the middle. I think this looks like the middle here. So if I kind of do this one. So there's the perpendicular bisector for that side. Whoops. And then this side here, same thing, midpoint that way. So when you have a right angle, a right triangle, okay, we'll call that a right triangle, your circumcenter is going to be on one of the sides of the triangle. More often than not, it's going to be on the hypotenuse. And then I think the other one is if you have a obtuse triangle, best I can do, here's the midpoint here, I'm going to say. So that's one midpoint. I'll continue it down. Midpoint here for this side. Again, might be outside. Yeah, it looks like I was outside. And then a midpoint here, best I can do. So see here now, my perpendicular bisector is all connected outside the circle, outside the triangle. So even though it's circumcenter and you're thinking it's inside the triangle, it does not necessarily have to be that. It's just something to think about and something to remember. Okay, angle bisectors. The angle bisector divides an angle into two congruent angles. I think we all remember that. Again, we have some theorems for this. The angle bisector theorem, if a point is on the bisector of an angle, if a point on the bisector of an angle, then it is equidistant from the sides of the angle. So if we kind of drew an angle, we have our bisector, so these are congruent. What they're saying is this point kind of this way, it's equidistant that way. Terrible drawing. Hope it makes sense. Just remember that any point on the bisector line of the angle is equidistant from the sides of the angles. That's going to be perpendicular to the sides as well. The converse of that, any point, if a point interior of the angle, if the interior is inside the angle, is equidistant from the sides of the angle, then it's on the angle bisector again. And then the last one, the in-center theorem. Angle bisectors of a triangle intersect at a point called the in-center, and they're all equidistant from the triangle. We'll talk about that in a minute. There actually is a special relationship for those, or a rule about those. So our example, MR is the angle bisector of NMP. Bisector, we're trying to figure out what the measurements of angle 1 and angle 2 are. We're given some algebra equations for that. I know angle 1 plus angle 2 is going to equal the measure of NNP, but it's the bisector, so then I know I can do, we're able to set them up. 5x plus 8 equals 8x minus 16. So now you just solve it for x. Add 16 to both sides, because again, I love positive numbers. Subtract 5x. You're left with 24 on the left, 3x on the right. Divide both sides by 3. X equals 8. Plug that back into our equations. Angle 1 equals 5 times 8 plus 8. That's 48. Angle 2, 8 times 8 minus 16, which is 64 minus 16, which again is 48. You always kind of want to check just to make sure. But there we go. Make sense? I think this is stuff we've kind of talked about before. Oops. Went too far. Okay, so your turn. Take a few minutes. There should be 4 or 8 problems, I think. To find out the difference measurements, whether it's an angle or, yeah, it's always going to be an angle. Angle bisector is working on, dummy. So take a few minutes, find the measures of the angles, and come back and we'll go through it. Okay, so looking for the measure of angle ABE. So we kind of look, ABE is the other side of our bisected angle. If one side's 43, other side has to be 43. Same thing for number 2, YBA. We're looking for the other bisecting angle, 47 degrees. And number 3, we're looking for segment MK. Again, we're talking about when the bisector, or point on the bisector, which we have here, our segments kind of connect. So that point is equidistant from each side. So that means the left side here equals the right side. So we're going to have 2x plus 1 equals to 3x minus 8. Solve that through. X equals 9. Plug that back in then. I get this is 19, this is 27. Lost my head for a minute. 27 minus 8, 19. I was thinking it was 21. Whew. Been a long week, everyone. So yeah, so both sides there equal 19. See if angle does move. So here they're pointing at the angle. That's not worried about the angle measure, or the segment measure. So again, 7x plus 5 equals 3x plus 21. Subtract 5. Subtract 3x, sorry. I end up with 4x equals 16, so x equals 4. Plug 4 in, I got 7 times 4 plus 5 equals 33. So our angle measures are 33 degrees. That makes sense to everyone. Okay. I misspoke earlier. There really isn't any special relationship with the in-center. All we know is that the in-center just creates equidistances from each angle. They want us to find the measurements of these segments based on what we're given of segments or angles, based on what we're told in the picture. So we're looking for side MU. Side MU, they're telling me is, PU is 5. So the point, that should be equidistant, so MU should be 5. The measure of angle UGM, I kind of try to find it, so I got angle UGM. Okay, so that's this angle here I'm looking for. So I'm going to call that angle 6. So that's going to be 28 degrees. That makes sense? Everybody saw that? All right, awesome. Angle PHU. So look, PHU, that's the other angle opposite to 21, so this is going to be 21 degrees. Okay, awesome. Now, they want us to find the measurement of HU. So what's HU telling me? Let's take a look. HU, I'm going to do it in purple. I'm actually going to do it in a highlighted color. Do highlighted green. So they want us to find this side. And we really don't know anything about that side because they haven't really told us anything. So we're probably not going to be able to find it. Do you think we were able to find something? Were you able to see something in the picture that helped you find that side? If you weren't, that's okay. Now that I've highlighted it, maybe take another minute and take a look. See if you can figure it out before I give you the answer. I'm just going to give you a few seconds here because it should ring a bell and look right away. But if not, what you're looking at is they tell me that this angle here is a right angle, which tells me this angle here is now a right angle, and now I have a right angle with 2 legs and a hypotenuse. So to find HU, that's just going to be the Pythagorean theorem. 5 squared plus 12 squared is going to equal, I'm just going to call it HU squared. How about that? So 25 plus 144 equals HU squared. This is 169. HU squared, which taking the square root of both sides becomes 13. So HU is 13. Again, we're kind of stretching in what other information have we learned to take measurements from angles. Hope that wasn't too much of a trick on you and you were able to figure that out because that was a good question. I like that one. And we will put that, something similar to that, on a test. Okay, medians. Medians are new. Medians we're going to talk about. Median is a line segment that connects the vertex of a triangle to the midpoint of the opposite side. The line doesn't have to be perpendicular. In some instances, it might. Mostly, they'll be equilateral triangles that then it will be perpendicular. But some triangles, it's not going to be, so it's just a point to the midpoint of the opposite side. The medians of those, the three medians of a triangle then intersect at the centroid. It's always in the middle. So the centroid's always going to be in the middle. Circumcenter, outside maybe sometimes. Centroid is always inside the triangle. And what it does is the centroid is then located 2/3 of the distance from the vertex to the opposite side. So when you're looking at that and thinking it, okay, it's going to be 2/3 of the distance, we're able to then figure out measurements depending on what they've given us, and we're going to be asked to do that in some of these problems. So just remember, the centroid is 2/3 of the distance. So here's our example. In triangle ABC, they're telling me U is the centroid. So they've told me it's the centroid, so now I know that this point, if I just look at line AU is 2/3 of the distance from A to S. So if you just kind of wanted to look at it, I could write, this is 2/3, this is 1/3. That would be the whole. So now they're asking us to find segment UK, the measurement of UK and BK. So now I'm on this line. I'm going to highlight it in red. We're on this line. And they tell us BU is 16. So this is 16. So that makes sense. Okay, if that makes sense, now we just got to figure out what UK is. Well, so let's kind of look at this. We're going to kind of do it in segment addition form right now. BU plus UK equals BK. So that's what we're looking for. Add BU to UK, we'll get the total distance. The definition of my centroid tells me that BU is 2/3 of BK. Does that make sense? Kind of like we're going to kind of put some numbers in. But they've also told me that BU is 16. So 2/3 of BK equals 16. So if you can kind of see where we're going, we're going to try to figure out what BK is. We're going to divide both sides by 2/3, or we're going to multiply by the reciprocal. Multiply by 3/2. That's just like dividing by 2/3. When I do that, oops, that should be 2, sorry. Those cancel, so I'm left with BK equals, this I can reduce to 1. That becomes an 8 with my cross canceling of the fractions. So BK ends up being 24 units, or whatever it is. So then I know if BU is 16, the whole thing is 24, that makes UK 8. I know I kind of went through that quickly. I think this video is starting to run a little bit long. Just want to get through it. Does that make sense to everyone? Did everybody see that? Because there is problems that we're going to be working on that deals with that. Okay. Here's your picture. Remember, that points to centroid. Everything is 2/3. The long sides are 2/3 of the segment. The short segment of the point is 1/3. They're asking you to find all those different segment lengths. You can do it from the information you have. It's actually not that hard. So take a few minutes, plug in your answers to Edpuzzle, and then come back. Okay, again, UD. Where are we? So they tell us AU is 16. They actually filled it in for us. They put the 16 in there. Just like the last one we did. They want UD. If this is 2/3 is 16, UD is 1/3 of that whole length, so that's going to be 2/3 divided by 2. So UD is actually going to be 8. Hope that made sense and kind of was easy to pick out. When you kind of have the inside length, whatever one they give you, either divide or multiply by 2, and that'll give you the other side. EU again, we look at EU. EU was on B to E, so this is 2/3 of the distance from B to E. So again, we're going to divide by 2. That's the distance of E to U. So EU is 6. CU. All right, let's take a look at CU. CU, they don't really show us anything, but they tell us that CF is 18. So we're dealing, this is 2/3. So the easiest math to do is if CF is 18, I can divide that in 3, and then 2 of those thirds is going to be CU, so that's 12. Does that make sense? Everybody see that? Okay. AD, we look at AD, well, we've already kind of solved that. AD is 16 plus 8, so that's 24. UF, again, we kind of already solved that. It's just the rest of our CF, which was 18 minus 12. That's going to be 6. And then BE is that whole length. Again, that's just 12 plus 6, so that's going to be 18. Did everybody see that? Did that kind of make sense? Hopefully I didn't go through that too fast. Again, if you have questions on this, we'll go over it again on Monday and kind of make sure we understand. Okay, whoops, went too far. An altitude. I just drew a triangle and we're going to kind of put them in. The altitude is the segment from a vertex to the opposite side meeting at a right angle. So in some triangles, the altitude is going to be the perpendicular bisector of that side. Sometimes it's not. Again, they all meet at a place called the orthocenter. There's really nothing we can do with them in terms of what the orthocenter does or doesn't do. You just need to know what it's called. I do the best I can to try to draw these perpendicular altitudes in on this triangle here, just so you can see it. And sometimes the altitude is going to be really close to the triangle, depending on how the triangle is shaped. So this one's a little easy to do. So altitude from our top point here, best I can do, the perpendicular bisector. It looks pretty close to being the equilateral triangle. Same thing here if I kind of draw this one. Whoops. The menu popped up, sorry about that. Again, best I can do. And then that once you kind of draw 2, you know where the third one's going to meet. Again, there's that. There's really, like I said, there's nothing we can do because all these measurements all don't mean anything. You can start kind of figuring stuff out with what we know about equilateral triangles and stuff. I'm sorry, those weren't supposed to be perpendicular. Oh no, they are right angles, my bad. So that did work. The first one's not good though. I'm sorry, I did it freehand. So just know that the vertex, the altitudes are perpendicular, and they may actually end up being the perpendicular bisector of the segment. They may not. More often than not, they're not going to be. And if you have any questions, like I say, bring them in on Monday. Try to do your homework, and we'll see how it goes. Have a good weekend, everyone.